Hello. So we are here today with Romain Eco from AIRBUS. Romain, maybe for our audience, can you introduce yourself?
Sure. So Romain Eco, I'm working for AIRBUS in engineering and in a department which is Central Method and Tools. So I'm working within a team which is called Digital Twin, and we are developing, deploying and supporting solutions based on Digital Twin for AIRBUS.
Excellent. Can I ask you one question? So we talk about virtual twin experience, you said digital twin,
Yes.
But can you tell us with your words what this is about?
For us, the virtual twin or digital twin starts when we start to re-inject data captured from the real world on the virtual models. If it's a bit different from having models design or stress information digitalized, it's become a twin for us when we start to put information coming whether from manufacturing, inspection during manufacturing or in service into the models to accelerate, for example, decision making.
Can you give us a few examples of how that can be used and why this is game-changing for a company at the scale of AIRBUS?
So it's getting game-changing because we are now trying to have a data-centric approach. So to take our decision based on data, not based on experience or judgment. Several examples. So typically, if we are able to re-inject into the design world data coming from in-service, you can take the example of corrosion findings or defect findings from operation, we can improve our product based on this data exposition onto the models. And we have been able to do so for example, for the single aid program. That's an example. It's also, during manufacturing, we also have some value to gain here, where we are able to inject manufacturing information directly into the backbones through the virtual twin environment, such as work order status, for example.
But tell me, in my mind, manufacturing people, they're on the shop floor, so they don't have a big PC. So how do they access virtual twin experience?
That's true. That was a constraint of deployment, in fact. But thanks to the 3D experience we can have now on smartphone, it's getting easier to provide this solution to workers. So some of them are starting to use it on mobile directly at the shop floor level, which also, by the way, solving problems such as connection, Wi-Fi connection, because if you are in 4G or 5G, it's working everywhere. And it's easy access, especially to the young generation, to the virtual twin solution.
That's very interesting. So imagining people with a mobile phone looking at the real physical plane being constructed and having the virtual representation on the phone, that's amazing. Can you tell me, I'm curious to know more about the adoption, because I can imagine, people that used to work with DMUs and 3Ds, although they understand 3D. What about the adoption in the plant?
In the plant? It's true that at the beginning, it was, let's say, kind of a fear that we will have some trouble to propagate that methodology into the shop floor. But at the end, and especially also because we are hiring currently, so we have also a new generation coming at shop floor. At the end, we see that the 3D bring a real value. To give you a concrete example, on one of the topics, when we train the people, we start to show them only the data. So where they can find the data, where they can find the panel information to close it through the tool. And then we show them the 3D. And that was that way we train people. But at the end, they all came back to us saying, no, start by the 3D. Because we want to see the 3D, it's helping us a lot to locate ourselves with regard to the aircraft.
Excellent. So if I summarize, 3D as a single way of representing what's happening in the real physical world, empowering people on mobile condition with the ability to compare what they see in the virtual world and what they see in the physical world, so that they can take the most relevant action, having the entire context in one screen, mobile. Yes. That's a major change.
Exactly.
Congratulations.
Thank you.
Thank you very, very much, Romain, for this testimony.
Thanks a lot.